Use the sample data and confidence level given below to complete parts A through D. A Research Institute poll asked respondents if they prefer online classes to face-to-face classes. In the poll, n equals 1,235 and x equals 439, who said yes. Use a 90% confidence level. A. Find the best point estimate of the population proportion P. In this case, we have a sample proportion P hat, which is 439 over 1235, and that right now is the best estimate of the population proportion P. That is approximately 0.3555, so you can say approximately 36% state that they prefer online classes. We're going to work with exact fractions though, so that our numbers come out better. Then it says B, identify the value of the margin of error. So the formula you're going to use, margin of error is E. E equals, we're trying to estimate a population proportion, and we are therefore going to use the Z distribution. So Z sub alpha over 2 times the square root of P hat Q hat over N. P hat is 439 over 1235, and Q hat is 1 minus that. So the first thing that we need is we need this Z sub alpha over 2. So we're working in the Z distribution, and we know the confidence level that we're going to use is 90%. Therefore, alpha is 0.10. So confidence level 90% is 0.90. Alpha is 1 minus confidence level, so it's 0.10. Alpha over 2 is half of that, so it's 0.05. So if we look at the Z distribution, 0 would be in the middle. We look at the two tails. The area that makes up both tails, the combined area of both tails is 0.10. One tail is 0.05, alpha over 2. So our Z sub alpha over 2, the critical value of Z, would be right there. So we need to find the area such that to the left is 1 minus 0.05 or 0.95, and we can use inverse norm. So number 3, we want the cumulative area up to Z to be 0.95 because the area of that tail is 0.05, and this is 1 minus. So we get 1.6448. When you get this answer, it's 1.645. The table would give you 1.645, so we're going to go with that. You only need the positive one in this case. You don't need the negative. You need the absolute value of Z sub alpha over 2, so 1.645. So now we can plug our numbers into this formula. And what I'm going to do is I'm going to use fractions. So P hat 439 over 1235. To find Q hat, you just do 1235 minus 439. So that's 796 over 1235. And then all over N, which is 1235. So now E, margin of error, and we're going to take this out to 4 decimal places. You would get 0.0224. So that's the margin of error. Now it says construct the confidence interval. So from our P hat, you subtract the margin of error to find the lower boundary, and then from your P hat, you add the margin of error to find your upper boundary. In other words, P is between P hat minus E and P hat plus E. And a better way to actually state that is we are 90% confident that the boundary constructed by the lower boundary and the upper boundary, which we're going to find in a second, actually does contain the true population proportion. And we're stating that with 90% confidence. So P then would be greater than 439 over 1235 minus 0.0224, and then the upper boundary 439 over 1235 plus 0.0224. And then for the final one, I'm going to round this to 4 decimal places as well. And this is part C. So it's 0.3331 and 0.3779. So that's your confidence interval for the true population proportion. I'm just going to read how you interpret this rather than write it. So for D, we can say with 90% confidence that the interval from 0.3331 to 0.3779 actually does contain the true population proportion of those who would say yes to that they prefer face-to-face classes or online classes to face-to-face. Okay, find the sample size needed to estimate the percentage of Republicans among registered voters in California. Assume that you want to be 95% confident that the sample percentage is within 3% of the true population percentage. Complete parts A through C. All right, so this is dealing with proportions. So we need a formula for proportions, and it's saying find the sample size. So that means we need to solve for n. So we need a formula that works with n. In part A, it says, assume that nothing is known about the percentage of Republicans among registered voters in California. So, for A, we are going to use this formula. N equals Z sub alpha over 2 squared times 0.25 over E squared. Okay, now, we know what E is. E is the margin of error, and it says we want to be within 3 percentage points, so that's E. So 0.03 is E. But we need the confidence level in order to figure out our Z sub alpha over 2. So it says a 95% confidence level. So confidence level is 95%. That means alpha is 0.05, and that means alpha over 2 is 0.025. So looking at a Z distribution with 0 in the middle, Z sub alpha over 2 would be right here. The area to the right is alpha over 2, or 0.025, meaning the area to the left is 1 minus 0.025, or 0.9750. So we can use inverse norm to find that. And we want 0.975 this time. So 1.96, which is the value the table would give as well. So 1.96. So that's called the critical value of Z. So now plugging this into our formula, 1.96 squared times 0.25 over 0.03 squared. So the margin of error being 3%. 3% as a decimal is 0.03. Here we get 1,067.1. So n has to be greater than or equal to 1,068. You want to round that up to the next. Always round these up to the next one. So now B says, assume that a recent survey suggests that about 30% of registered voters in California are Republicans. So for B, we use a different formula when we know something, or we have a sample proportion to work with. So n is Z sub alpha over 2 squared times P hat times Q hat over E squared. So P hat in this case is the 30%. 30% as a decimal is 0.30. We didn't change the confidence level, so we used the same critical value of Z, 1.96 squared, times 0.30 times 0.70, all over 0.03 squared. So here we're going to get, n equal to 897. Actually, it's 896.37, which you would then say n is greater than 897. You always round up. So C says, does the additional survey from Part B have much of an effect on the sample size that is required? It did reduce the sample size required by, I don't know, more than 100, 160 something or other. So it did reduce it, but I wouldn't say it reduced it substantially.